A few weeks ago, Vercel released their own open source vibe coding platform. I went through the whole repository and now I completely understand how it works. And today I wanted to share with you my findings and my learnings from this repository, patterns that I disagree with, things that I like, things that I don't like, and things to improve. So if you're a dev and you want to learn more about how it works under the hood, this video is exactly for you. So let's get into it. Let's look at the UI of the platform to understand how it works from the high-level perspective. First, what you will notice is that we have 4 basic components. Here on the left, we have our usual chat where we can see all the events or tools that AI called. We can see all the messages. On the top right here, we have our web preview. So here we are going to see our web application. In the middle, we have our remote file system where we can preview all the files that AI has generated and we can see the file tree. And at the bottom, we have our terminal where we can see all the commands that AI has ran and all the logs from those commands. So if we send our message, what you will notice first is that AI creates a sandbox, and sandbox is basically an environment where we're running all our code and where we're creating all our files. After that, AI calls another tool to generate files in this sandbox. So it creates package JSON, all the pages, and after that it decides to do that again for some reason. I don't know why. After that, it's running a command to install all the packages. And after AI created all our files, we can see them here in file tree in our Sandbox remote file system. And at the bottom in our terminal, you can also see the command that AI has ran. So you can see that it's called pnpm install. After that, it started our dev server with pnpm run dev. And we can see all the logs here. And only after that, it decided to get the sandbox URL so that we can preview it on the front end. And after some time, you'll notice that we have our application here. Also in file system, you can preview all the files that AI generated. Also, one interesting feature that they have implemented is that if we have any errors in our terminal, we're going to send those errors as a user message back to AI so that AI can resolve it, which is pretty cool. Okay, now we understand the high-level implementation of how it works. Now let's get into the code and understand it from the inside. I think it's really important for us to understand where it runs its code, where it stores it, and how it works under the hood. And for that, as I said, they're using Vercel's Sandbox as their service to provide very easy to use virtual environments where you can run like untrusted code. And they have made it really simple and straightforward for you to create the sandbox and run commands. And to make it work, all we need to do is install Vercel Sandbox library, import Sandbox. After that, we can create Sandbox with the create method, write which ports we want to expose to the public. Here you also have like a multiple different methods like timeout. So timeout is basically how long the sandbox will live. You can also specify the runtime. So it could be Node or Python. I believe by default it's going to be Node, right? Yeah. After we created our sandbox, it's really easy for us to write files. All we need to do is call methods like write files, specify the path relative to the sandbox. So it's going to be like a root directory, and we're going to create a file package.json, and here you can imagine we'll write the content, or AI will write the content. And after AI wrote all the content and created all the necessary pages and configs, then we're running the commands. Again, it's super easy. All you need to do is to call the method run command, where first argument is command. In our case, it's pnpm, and second, it's arguments. And we're specifying pnpm install to install all the dependencies from package.json. After that, we need to run dev server so that we can access the website itself. So we need to, again, run the command pnpm run dev. And after that, we're calling the sandbox.domain and specifying the port that we specified earlier. And after that, we will get the URL of the sandbox of this port, and we can access it on the web. And you can imagine that's how we are displaying the application that AI has generated. And we already can see how it all comes together, where in the demo you saw that AI has called the creation of the sandbox. After that, it wrote files, and after that, it ran commands. So I think it's really important just to understand how it works under the hood before we even get to the agent. Okay, now let's look at the route that we're calling when we're sending a message. First thing that you will notice is that we're checking if you are a bot or not. And I don't think this library, what is called bot ID, I don't think this library is getting enough credit because how easy it is to set up like CAPTCHA and to check if you're a bot or not. So if you're really interested in CAPTCHAs, please look into this library. It's super easy to set up, especially if you're on Vercel. After that, we're doing a few things. First, we're getting the models, all the available models. So, and if we look at this function, you'll notice that I changed a few things. Previously, they were using Gateway, so Vercel's Gateway. It's their alternative to OpenRouter, but I haven't had any credits there. And on OpenRouter, I have like a $20 worth of credits. So I decided to just switch it up a little bit, but it was super easy to change. All I needed to do is to change the instance here from gateway instance to OpenRouter and change the URL to API key and insert my own API key. And also after that, I needed to change some of the constants. So they have this constant for all the models that are available in their application. If you go into this enum, and here all I needed to do is to change some of the names right here, because they were a little bit different. And also I added Grok 4 Fast just to test it out, see how it works. And that's pretty much it for the migration from gateway to OpenRouter. If we go back to our route, so we're getting all those available models right here. Yeah, and also we need this function because we're also like exposing it on the front end so that we can like show in the selector which model you want to use for the request, for the message. After we got all our models, we're also, you will notice that we're getting the model ID. So with each request, with each message that user sends, we're also sending the ID of the model that user wants to use. We're searching for this model in all the available models that we have. If we don't have this model, then we're just throwing an error. After that, we're creating a stream, create UI message stream, and this allows us to access the writer, and writer allows us to send a custom data to the front end with the stream. And how I like to think about parts is that model previously could only output like text in the message, but now each message contains parts. Each of these parts can be different types. For example, it could be file, it could be again text, it could be some different type that you specify, and on the front end from those types you can map out and create beautiful UI from it. Here we're specifying stream text to stream the AI's response. After that, we're specifying get model options based on the model ID that user has provided. And if we go into get model options, it's just a function that allows you, based on the model ID, get different options for the provider. So for example, if we specify, oh my god, if we specify OpenAI GPT-5, we're providing like different reasoning effort, reasoning summary and stuff like this. For Anthropic, it could be like cache control, and by default we're just returning the model. Another interesting thing that they're doing is that they're not inserting the prompt here as a string, but they're storing it as a markdown file where they're specifying all the information in the file and not in the separate file and not right here. And it makes sense because the prompt is quite long, which improves the readability in the first place. But other than that, I didn't see any interesting patterns in the prompt, to be honest, and just an explanation of what it should do, and that's it. I saw somewhere that they've worked with OpenAI on improving prompts to get it to make it better, but to be honest, I haven't seen here anything that interesting. Let's quickly go through the prompt of this agent. So first we're specifying the role of this agent, that it's a vibe coding agent. We're specifying that it's integrated with Vercel Sandbox, which is interesting. That it's working inside of the sandbox and that it's solely responsible for it, which is funny. Then we're specifying critical rules to prevent loops. So you can imagine that sometimes AI can overthink and overlook some of the steps and, for example, infinitely create files. And so to prevent that, there we have some of the rules, or for example, when it's fixing errors, it can get stuck. And so we're helping and navigating AI to make better decisions. Then you will notice that we're always saying to prefer Next.js, and we have some of the rules for Next.js. Then we're saying to not create some of the files, for example, like log files or .next.js files, not modules files and stuff like this. Then we're saying to focus on the front-end and front-end logic of the application. After that, we're specifying our tools, create Sandbox, generate files, run commands, wait command. I don't think they have this tool, but I think they forgot to remove it or something, and get sandbox URL so that we can access the application itself. Then we have some of the behavior principles, like always use one sandbox, not create more than one sandbox, only use relative path, session tracking, session state tracking. So some of the rules to make sure that it works properly. And after that, again, we're specifying critical rules to prevent loops, but now for error handling. So they probably had a lot of issues with that. That's why they put two different critical to prevent loops blocks in their prompt. You'll notice that the first one was in the beginning somewhere, and now it's close to the end. It's like another thing to remind AI. So if you have some kind of task that AI should do always, and it's very important, you can try to put this part of the prompt in the beginning and in close to the end to the prompt, because sometimes AI can lost some of the context in the middle of the prompt. I heard that it's usually happening with larger prompts, but they're doing it right here. So I guess it works for them. After that, they're specifying session workflow, so what AI should do in what order. And I'll talk about more why I disagree with some of the steps here and about the workflow itself. Then they're specifying that it should minimize reasoning, so that before each tool call, it should just output 1 to 2 sentences maximum why it called this tool. And after that, it just summarizes all the steps that it's done. And that's it for the prompt. I expect it to be shorter, to be honest, but they're going into many details of implementation of what it should do. So I guess it's working for them. But in your application, you should probably keep the system prompt as short as possible. And if your prompts are getting this large, it means that your agent probably is doing too many steps or too many actions, and you should probably break it down into smaller pieces. Okay, but now let's get back into the route. After that, we're converting our messages into model messages. What it essentially does is that it goes over all your parts and removes all the custom parts and format it in a way that we can send it to AI. So for example, if you need to send custom parts as a text, what you would do is you would iterate over each message parts, like so. You would find your custom part and you would insert it like this. So you would specify the type text and insert your text. This way, your custom part will be actually sent to AI and not get lost. After our messages, we're specifying when to stop. So when the step is 20, then we're stopping the agent loop and we're just stopping the iteration. And if you need to continue, you would probably write continue, and then it will continue all the steps. Then we're specifying tools, and you will notice that tools are a function where we're passing the model ID, which means that we'll probably use separate call to the model inside of the tools. And we're passing writer to actually write custom data to the frontend from those tools. So it could be intermediate state of the tools. Then we're specifying errors, just console log. Then we're specifying consume stream. I don't, to be honest, remember what it does. So it says that it consumes the stream without processing its parts to force completion. From the top of my head, I can't really tell how to use it and when to use it. So if you know, let me know in the comments. After that, we're doing writer merge. This allows us to merge multiple streams into one. So we have one stream, which is our AI stream, AI text that AI generates. Another stream is this writer. So you can imagine that we have writer as a stream and we have our AI, and we're merging them together. That's what writer is for. And here you will notice that we're specifying send reasoning and send start. It's just events. Basically send start on the front end, you have on start, I believe, event or something like this. And we can specify whether or not we want to send it. And send reasoning, probably you can understand that whether or not to send reasoning to the front end. And message metadata, just to show on the front end which model we used. Okay, now let's get into the tools. I think it's the most interesting part of all of this. So here we're defining tools as a function, and the reason why we're defining them as a function is because we want to pass additional information such as model ID and writer. And in return, you will notice that we're just returning all 4 our tools that I've discussed during Sandbox demonstration. So we have our create sandbox, generate file sandbox, get sandbox URL, and run command, and I'm gonna go into depth in each one of them. Okay, let's start with the create sandbox. You'll notice that again, it's a function, and this allows us to pass writer into this function. And we're returning a tool. So it's a function from AI SDK. We're specifying description, which is again a separate file with its own description. It's quite lengthy. And I don't want to go into each prompt of each tool and describe it in details, but what essentially it says that we should always create only one session. We're explaining what the sandbox can do, that we're returning the session ID, sandbox ID from this tool. So what we have here in input schema, so what AI has to input into this tool is that we have timeout, so how long will this sandbox live, and we have ports. So again, which is strange to me that AI specifies the ports that we should use and the duration of how long the sandbox has to live, but that's how they do it. Then we're specifying execute function where we're getting the timeout and ports. Here you will notice that we're calling writer, the thing that we've passed into our function. We're calling writer write, and here we're specifying custom data type, which is data create sandbox, and we're specifying status loading. Then we're just creating a sandbox as I showed you, and specifying in the writer again that sandbox was created, and we're returning the sandbox ID back to the front end. And we're returning to AI this sandbox, and we are saying that it was created with ID, and now you can upload files, run commands, and access services on the exposed ports. Another interesting pattern that I noticed in their repository is that they have separate function to get reach error, where you're specifying the action, so where the error happened, and the error itself. So inside of this function, what we're doing is that we're formatting this given error into more readable for AI format, and then we're returning it with a message and error, and returning back to AI, and the AI then decides what to do with this. So that's that for Create Sandbox. What I like about all of this is that we're always keeping the front end updated and up to date of what's happening inside of the tool. And we can do it because of the writer and custom data types. Now let's look at the next tool. First, what you will notice is that, again, it's a function where we're passing writer and model ID, which means that most likely we're going to use another call to AI to generate probably file content. Inside of this tool, we're defining again the description, input schema, and inside of input schema, you will notice that AI has to input the sandbox ID, which it generated in the previous step, and paths. And path is basically going to be like /app/layout.tsx /app/page tsx, etc. After that, we're immediately calling writer write to notify the frontend that we started generating files. After that, we are defining the sandbox. Then based on that ID, we're trying to get it from sandbox.get. If we didn't get it, then we're passing error to AI and writing as a custom data type that this failed. After that, we're defining two helper function. First, which is get write files, which is just a wrapper around write files with additional like error handling and notifications to the front end. So here, for example, we're defining that those paths are uploading now. And after they're uploaded, we can notify the frontend that, or the client that they were uploaded. And error handling as well here with get reach error. And in this helper function, we're passing again sandbox tool call ID to define the ID of the writer and the writer itself. So that's that for this function. Next is get contents, and what you will notice is that we're passing the model ID, paths, and messages. So inside of this function, you will notice that first that it is a generator function, which means that we can partially output the data and not just return the whole thing. And that's exactly what we're going to do here. So first we're defining the empty state, generated files, which files were generated. And the third is just for error handling. I'm going to show you how it works. Then we're defining the stream object. Again, we're getting the model option based on the model ID. After that, we're defining the system prompt that it must generate files based on the conversation history. And then we're passing the paths that first AI, which is a parent AI, decided to generate right here. Here we're defining the schema, which is file schema, which is path and content for this path. After that, we're starting to iterate over the stream. And so here what we're essentially doing is that we're ensuring that each chunk that is going to be generated here, each chunk is going to be the finished file and not the partial file, which is important for us because on each iteration, on each chunk, we're going to upload files. And so here we're just making sure that we're yielding the finished files and not partial ones. And if files are partial, we're going to just yield the empty files. After that, we're defining the promise race, which means that if, for example, this promise will resolve first, then we're going to get this result of this promise here. If this is going to resolve first, then we're going to get it here. So it's like a race, which one will finish first. And most of the time, this result will be resolved first, which means that there are no errors. But if this deferred promise will get resolved, this means that, so I'm going to show you. Remember, we defined this deferred value here, and we're doing deferred.reject in on error. So if streaming for some reason fails, we're going to reject this deferred value, which means that this promise will get resolved first, which means that we don't have a value here, which means that something went wrong because we don't have a result of this object, but we have this deferred value, which means that this is an error. After that, again, we're yielding all the files that were generated. And that's it for this function. Then we're getting iterator from get content, iterating over it. Now we know that each chunk is the finished file. And based on that, we can be sure that if we have files here, it means that it's fully generated file. If we have an error here, then we're just returning the error. If we don't have an error, we are just uploading. We're pushing this generated file to uploaded array right here. If chunk doesn't have a file in it, this means that we're still generating it. That's why we're using generator function to partially yield partial data to the parent. And so here we're notifying the client that they're still generating. If everything went smoothly, to the frontend, we're writing now all the uploaded files with the status done. And we're returning to the AI that files were generated and uploaded and paths to them with the content. Next tool is get sandbox URL. If we go into this function again, we're defining it as a function and passing writer into it. If we look into it, input schema is sandbox ID. So AI has to provide the sandbox ID and the port, which is again strange to AI to provide port, but I'm going to talk about it a bit later. After that, again, we're writing to the client that we are getting the sandbox URL, getting the sandbox from the ID that AI provided, and doing sandbox.domain with the port, again, that AI has provided to get the URL that will be accessible to the client. And then we're just writing to the client again that we have successfully retrieved the URL of the sandbox with the status done, and we're returning the URL of the sandbox back to AI. So next tool is run command. Again, we're defining it as a function, passing the writer. Here, AI has to input the sandbox ID, command, and argument. So command is npm, not Python as it says here. And command is like install or verbose. Then AI has to provide whether or not it's a sudo command for permissions. And then AI has to provide wait command, which is whether or not we want to wait for command to finish before returning, which is again a bit strange. Why would you want to return earlier than command finishes? After that, again, write, we're notifying the frontend that we're executing it, getting the sandbox. if any error, if any errors, we're notifying again the frontend and sending error back to AI. Then we're defining the command, and based on the parameters that AI gave us, we're executing this command, and again handling errors with all the same things. After that, we're notifying the frontend that the command that AI has called is now executing. If we don't have to wait, then we're just returning it with the status running and returning it to the AI that this command has been started in the background. If that's not the case, then we're waiting for command to finish. And when it's done, we're just again writing, returning the response back to AI. And that's pretty much it for this tool. So here's how our system works right now. We have AI and we have 4 basic tools. And what I don't really like about this is that we're doing clearly defined workflow through AI. So if you think about it, every time a new user makes a request, we want to create a sandbox. And in the end of each request, we want to get a sandbox URL to then get this URL to the user. So this is a clearly deterministic workflow if you think about it. The only non-deterministic things about it is generate files and run commands. And also because AI has to decide when to create a sandbox, we have to weirdly manipulate with this sandbox ID, with port ID, which also costs tokens if you think about it. With each request, with each time AI calls a tool, AI has to input the sandbox ID into the tool. So I think a better implementation of this would look something like this, where when a new user makes a request, we're always creating a new sandbox. Then AI doesn't need to think about creating a new sandbox or manipulating with this sandbox ID. It will just know that it's in the sandbox and it just runs commands, that it generates files, and we will through code provide all the necessary IDs. And when it's done, for example, AI can return the done flag. We can then get the sandbox URL and return it back to the client. And because we're managing sandbox ID and not AI, first it will cost much less tokens, and probably AI will be smarter because of that. And I also caught myself many times doing similar things like this. But how I like to think about it is that we have to think from the workflow and then sprinkle AI into places where it's not possible to do with deterministic code, and not the other way around. We don't need to implement AI for everything. We need to put it into places where it makes sense, basically. Of course, it works, but everything can be improved. And I think we can learn a lesson from looking at how they implemented it and how we can improve that. With that being said, let's get back into the code and see how the frontend works. So if we look at the structure, we have layout with some providers and adapters. We have our one page and 4 core components. I don't want to go too deeply into implementation of each one of them, but I want to cover state management and interesting patterns that I noticed here. So let's start from the chat. So here in the chat, we're getting the chat instance from a shared context. Then we're passing this chat instance into use chat, which allows us to reuse this one chat across many different components. Then here we have our usual chat interface. I don't want to go too deeply into it. If we look into the context of this chat right here, you'll notice that we're defining new chat. And here we have all our settings or event handling. And I think the most interesting part is this on data. So we have a separate store, which is Zustand store, to manage different states and events and to save them. So if we go here, you'll notice here that based on the type, we're setting different states. So for example, sandbox ID. And if we scroll up, we can see here all the definition of our sandbox store. You can look through the store, but basically everything that we were doing on the backend when we were writing writer.write and defining custom data types, we're handling all those events here. So for example, for paths, we're setting all the generated files, we're setting the sandbox ID with different statuses of the sandbox, and we're doing it through data.type. So we're just switch casing over all the predefined data types from our data part type. And so we're just setting everything to the store. This way we can reuse all the necessary data across all our application. So for example, if we go into File Explorer, you'll notice here that we're getting paths from our sandbox store. We're getting sandbox ID and status, go into the component, and we are from our paths, we're building the file tree, we're rendering the file tree, And the reason why we're passing the Sandbox ID here in our file explorer is that when you click onto the card, when you're selecting a file, we want to separately fetch the content of this file. So for that, we have a separate endpoint, which is API/sandbox. Let's try to find it. API, sandbox, files. So we're getting the content of the files based on the path, and then we're displaying it as a, as a syntax highlighter component. So everything is built around this one store, and we're just consuming all the content from the store across our application. One interesting thing that I wanted to share here is that we have error monitor, which was defined in layout here. So we have this component error monitor. The whole idea of this component is that it always listens to the commands in our terminal. And if we have any errors in our command, what we're doing is that we're doing a separate call to a separate AI. So if we go and try to find this API/errors, so we're sending here a request with the error, and this AI basically decides whether or not this error should be fixed, gives a quick summary, and paths where it should be fixed. So we have basically another AI that helps us to fix errors in our terminal, which is pretty cool. And after we got our summary, we're sending a message as a role user with the custom part data report errors, and we're sending data as a summary. If we go back quickly to the backend part, where we're defining the route of our chat. And so here where we're converting the model messages, we're going through each and every part, and we're trying to find this data report error that user sent, and we're parsing it into the text, because otherwise it would get lost. When we're parsing it, we are getting the summary, the paths, and giving like hints to AI about this error. Another thing that I wanted to cover quickly is how we're previewing the application. So we have a component, and if you remember, we have a tool to get Sandbox URL, and we're storing this URL again in our store. Here we're consuming it, and we're passing this URL. And what we're doing essentially is that we're, if we don't look at all the UI stuff, all we're doing is that we're previewing it through iframe, and that's pretty much it. And I think that's probably the most interesting parts of the frontend. I can go deep into each part of the frontend, but most of the components is just rendering the state from our Zustand store. That's pretty much it. So I hope you found something helpful from this breakdown. Not everything is great in this repository, a lot to change and improve, but I think we can learn a lot from this repository. So if you found this helpful, let me know in the comments, and I'll see you in the next one.